All right, good afternoon, everybody. We are Team Intel, and in our team, we have Zac, Allister, Javier, me, Safeeyah, Isaiah, Harshith, and our TA, Rinav. There you go. And this is our garbage classification project. Now, every year, millions of tons of unsegregated waste end up in landfills, which can produce toxic gases and contribute to global warming. We chose to make this product to help consumers segregate their waste to make sure it gets processed correctly and ultimately have a positive impact on our planet.
We collected 1,000 images or more for each of 11 different categories. We mainly use Google Images, but sometimes use datasets from Tagle and other sources to add additional data. However, noting that it would take longer to collect every image one by one, we used the Download All Images extension on Chrome to effectively collect all the necessary data at once. Then, using erasing software, we removed all watermarks and white backgrounds that would disrupt the identification of the image. After that, we were tasked with organizing our dataset. Our images mostly had the file names with several random characters, such as 12, AB, 12, something like that. And those were difficult to read and made it harder to avoid conflicts between the file names in different categories. So we programmatically normalized each of the data files such that, for instance, the images pertaining to battery after running our script would be called battery1.jpg, battery2.jpg, and so on. And here you can see all the different categories that we had for our detector.
We use the YOLO conflict file in which we set the batch, sizes, filters, steps, and classes before training, and we initially changed our model with 13 categories. Eventually, after hyperparameter tuning, we retrained several times with all the categories except 2 of them, since they were overlapping and causing too much error in the results. During the training process, we keep checking for the average loss to stay as low as possible, and also tested the model from a separate terminal to ensure that the model was training correctly. Ultimately, we trained into the weekend, and after several adjustments, we ended up with the mean average precision at 94%. Additionally, to compare both our precision and recall values, our F1 score was 91%, which ultimately meant that we had very low false positives and false negatives, and we were correctly classifying the garbage most of the time.
So an important part of making an AI is evaluating it afterwards in order to see how it performed and then adjust different elements to try and increase accuracy. In order to test the AI, we put aside 20% of our data after we collected it to be used for validation and testing. We then had the AI attempt to classify those images in that 20% and generated confusion matrices to visualize how the AI's prediction differed from the actual content of the images. And you can kind of see that matrix right there. So it shows like what the actual label was on the left, and then on the bottom it shows what the AI predicted. Yeah.
Now, realistically, when you're creating any product, you are almost predestined to run into issues, and our product was pretty much on that same basis. So out of the 6 major problems, the 3 ones that caused the most problems were the white backgrounds, watermarks, and the problems with YOLO crashing. Now, in order to combat the white backgrounds, we basically just removed any images with white backgrounds and replaced them with more realistic backgrounds. The reason for this was so that the computer has a real understanding of what's around. If everything is a white background, it's not going to get a real sense of the actual object. Moreover, in order to combat the YOLO crashing, we basically had to move from, I believe, CodeCalc 8 to CodeCalc 15 and reinstall the program. And finally, the thing about watermarks is that it would cause a corruption in the file, meaning the image would read something else. So we basically just use something known as APowerSoft to remove the watermarks.
All right, so from our experience, we learned collaborative teamwork and effective problem-solving skills, along with programming at higher levels. We also learned to make programs that are practical and useful to our environment. Moreover, we learned Python and how to effectively use those skills to our advantage for creating our product. And we also learned how to collect, sort, and label data to use for our machine in an expedited manner. Okay, so that's basically the end of our slides presentation. I'm gonna go ahead and switch my screen to the actual our website. All right, so this is the home page, which is basically kind of an extension of the motivation as to why we wanted to create this specific type of product. So this button right here, I'm going to use it to demonstrate how this object detector works. So what I'm going to do is I'm going to look up a type of waste product, and it's going to generate if it's recyclable or not recyclable. So I'm just going to look up aerosol can. Just going to go to images right here. And let's see this one. Pick this one out, and I'm going to go ahead and save it. All right, and we click try now. I'm just going to load the image into the website. And as you can see, with 77% confidence, the website detected this image as an aerosol can, which is correct. I'm going to try a different type of garbage waste. So I'm going to, let's see, look up, say clothes, because that can be a type of garbage. I'm going to go ahead into images right here. And let's just choose this one, for example. I'll go ahead and save it. All right, and then I'm going to load it again. Should be this one. And as you can see, it with 96% confidence detected the image as recyclable clothing material. And down here is just kind of more info as to why the detector might be incorrect. And here's a next detailed explanation of how to read the confusion matrices. And obviously this team, our team button up here just shows us our backgrounds and our pictures. And this behind the scenes tab right here, just really on a higher level, I guess, just explains how YOLO works. And this little section here is just a breakdown of how AI Camp went down over the past 3 weeks. And this little link button up here, it just takes you to the AI Camp website. And yeah, that's basically the website. Thank you for listening.
Thank you. Awesome. What can we like if there's someone who's going to buy this product, who do you think would buy this? What do you think?
Well, the overall intention of the product was to appeal to the everyday consumer. Obviously, well, I live in Las Vegas, so Republic Services, which is a trash company here in town,
yeah,
they basically gave us these like recycle bins and like trash bins that you put out on the street every night. And basically, like I've seen a lot of my neighbors, like they'll put non-recyclable things, in the recycle bin. And so the appeal of this product, so the target audience is basically just everyday consumers who are unsure if the items that they're tossing out are recyclable or unrecyclable, and overall are wanting to see if they can make a difference in the environment through their contributions.
Yep. Well said. I think this is something actually you can test. Yeah. Awesome. Thank you guys.